In this video, we're going to learn about neutralization reactions. Now, a neutralization reaction is where an acid and a base come together to form salt and water. In this neutralization reaction, the acid and the base neutralize each other, giving a pH of, or a pOH of 7, the neutralize each other. So the formula is an acid plus a base yield water and salt. Now, a common example of this is hydrochloric acid plus Cl plus sodium hydroxide. Now, this is going to form water, which is written as HOH. It's also H2O, by the way. You guys probably knew that. But people like to write HOH because it forms with this OH, with this OH group. You see right here, this OH group plus this H group forms this OH plus the remaining the salts, the NaCl. Now, as you can notice, this is a double replacement reaction because these two combine right here, and these two combine. It's a double replacement reaction. Now, if sometimes in problems they may give you the volume and the molarity of some parts of the thing, and ask you to find and solve for the other parts. But there is a formula which you can use to solve problems involving neutralization. So the formula is VaMa equals Vb Mb. Now, what that says is that the volume of an acid multiplied by its molarity equals the volume of a base multiplied by its molarity. Now, after you do this calculation, you must remember to apply stoichiometry, because sometimes the mole ratios are not the same. It's not just 1 to 1, and you have to multiply by the mole ratio after you've solved for whatever you want to do. Also remember to balance your equation. Balancing the equation is always essential. Okay, let's do some practice problems. Remember, this is the formula, water plus the salt. Now, how many milliliters of 0.2 phosphoric acid must be added to neutralize 0.75 ml of 0.5 iron 2 hydroxide? So first step is, you guessed it, write your balanced equation. Phosphoric acid, HPO4. PO4, polyatomic ion, has a -3 charge, so there's 3 H's. Plus, you're adding iron 2 oxide, or actually you're adding this to iron 2 oxide, which is FeOH. Now this OH is 2 because Fe is plus 2, is iron 2, OH plus 2, and this yields the products of hydrogen, as always, water, whatever, and what's left over? We haven't balanced this equation yet, just note, but let's have Fe and POH. Fe3PO plus Fe3PO4, which is iron phosphate sub 2, because this is a -3 times 2 minus 6. This is plus 2 times 3 is plus 6. So this is evens out. Now, to balance our equation, we must add 3 here because it's a 3 down here. And now there is, let's see, it's added a 2 here and a 6 here. I think that evens out, right? Yeah, that's all good. So now let's apply our equation VaMa, which is up here, VaMa. It says 0.2 molar of, we don't know the milliliters, times x equals 75 times, I don't know what that is, 75 times 0.5 times a half. Now, divide both sides by 0.2, find x equal, plug it into our calculator, 75 divided by 2 is 35.5, divided by 0.2, set 177.5. Did we do that correctly? I was lying. 75 divided by 2 is not 35.5. 75 slash 2 is actually 37.5 divided by 0.2. That should be correct. 187.5. 187.5. Now we're done. Yay, our volume. Just kidding. Just kidding. We forgot to file you in the mole ratios right here. So for every 2 of these, there's 3 of these. So times 2 over 3, because we want to know how many milliliters of this to add of the acid. So times 2/3 and 187.5 times 2 slash 3 is 125. 125. This is the correct answer. Wait, don't forget your ml. This was an ml, so this is an ml. Don't forget your units. Now right here, we are done. Now don't forget sig figs. If you're asked for sig figs, don't forget them. Next problem. 50 ml of 0.1 hydrochloric acid was added to 40 ml of 0.1 molar KOH, and the mixture was stirred and tested with pH meter. What reading should be obtained? Now, let's do the problem. So you have HCl, let's write our balanced equation first, plus KOH, and that renders HOH, as always, HOH, and what else? ClK, KCl, potassium chloride. So -1, +1, this all works out. Is this even? This is even. This is a balanced equation. I believe it's a balanced equation. Is it a balanced equation? Yes, it is a balanced equation. Now let's read what it says. 50 ml of this was added to this. What pH should be obtained? Now let's see. The water neutralizes, and there's KCl here. So you're saying, okay, it should be 7. 7, because it's a neutral reaction. Now that's wrong, because there's a different amount of HCl, and actually, not all the HCl will get used up in the reaction. There'll be some left over. Well, not all of it will be used up. So first of all, the total, let's find the total, let's find the moles, because if you use VaMa, Vb you might get one value, but then you forgot to value in the stoichiometric ratios. So VaMa equals Vb Mb. So let's do this. So the molarity of this is 0.1. So you have 0.1 times 50 equals 40 times 0.1. So what's going to happen in this reaction is that this is not going to react with all of this. Only 40 of it's going to react. So you're going to have 10 left over. So the pH is going to be the leftover. The pH is going to be 10 milliliters, the 10 ml left over. And that's of HCl. So let's find 10 ml of HCl, HCl over, erase this, divided by, so we want to convert this to moles first, because we want to find the concentration, to find pH, then you find the concentration of leftover H plus ions. So therefore, we need to find the leftover HCl. So it starts out with 0.1 molar of this. So molarity, if you remember, number of moles by liters. So this is, liters is 0.09. That's how many liters there are. So you can solve by doing 0.01 times 0.09 to get how many moles there are. 0.1 times 0.099 0.009. 0.009. That's how many moles there are of this. And then That's at the beginning. And then it reacts with this. And how many moles does it react with? Let's see. 40 ml of this. So you have 0.1 equals 0.004, no, 0.04 times, like, this is the value of the number of moles we want to find. So that number is equal to this times this, which is 0.04 times 0.1, that's 0.004. 0.0044. So let's compare this value to this value. So there is a difference of 0.005. So when you do the stoichiometric ratios, so So what we need to do is we need to find the pH. Now, just looking at this, you might say OH, H, neutralize. But no, there's a different number of milliliters of this, so they're not going to neutralize. There's going to be some, there are going to neutralize, but there's going to be some leftover HCl. So let's first find the number of moles of each. So let's see. 50 ml of 0.01, 0.01 equals, if you know what molarity is, the number of moles, which I'll put as X, over 0.05, which is the number of liters. Multiply that together, X equals 0.005. You can do the same thing with this, and you get that that's concentration, whatever X2 equals 0.004, not concentration, the number of moles for this. So then that means that there's going to be this of this 0.004 moles of this will react with 0.004. So this to form this. But then there's going to be 0.001. There's going to be 0.001 excess. So what are we going to do with this excess? It's going to form the pH. So 0.001, that's moles, over total number of, well, for the total volume, this is 90 milliliters, or 0.09 liters. That should get us, let's see, 0.001 slash 0.09, 0.0111, 0.0111 repeating. So, is that our answer? No, that is only the leftover concentration of HCl, which is also the leftover concentration of just H, because honestly no one cares about the HCl. So now we have to use our pH equals negative log, this is in molars by the way, negative log concentration of HCl 0.0111 repeating. So we plug this in and we get, let's plug this into your calculator, negative log 0.0111 repeating. You have to plug this into your calculator to see what you get the answer to be 0.0111. So negative log of, negative, sorry, negative log of 0.01111. Repeating, that will get you around an answer of 1.954. So that's our pH. It is acidic. So it's leftover H+. Don't forget your stick fix.